Welcome to this video where I explain how you can use the Java Persistence API within the Jakarta EE 9 specification. This is already part 5 of our Getting Started with Jakarta EE 9 series. So with JPA we can read and write our data to the database in a very easy way. So let's see what we need to do to achieve that. First of all, we need to configure the database. We will also look at reading and writing the data, of course, and go into more details about converters, parent-child relations, and some performance aspects. This video is split up in two parts. So the first one will concentrate on the configuration and the reading of the data. So let us look at a demo application for reading our data from the database. As with the other examples, we again define the Jakarta EE Web API artifact as a dependency of our application, as previously also with the scope provided. So the first thing we need to do is define the configuration for the database connection. The JPA specification uses the transaction specification, and that means that you can specify the database connection that needs to be used through the JNDI name for which that connection is available. So I will create within the server a connection. It's called local MySQL that connects to the MySQL database that I have running here locally. I do not need to specify here any username and passwords or the JDBC URL. That is all covered within the server itself. I specify here a few properties. These are for demo purposes because for production situations you should not drop and create your database every time your application starts, and probably you should not load some default data, but you can do it with the specific property names as we have defined here, the schema generation and the SQL load scripts source file. You also have the possibility to specify other properties. For instance, here I specified the logging level for Eclipse Link, which is the implementation of the JPA specification within Payara, to the level finest, so that we can see a lot of information of what the JPA is doing when we are running our application. Now that we have configured the database, we need to define the mapping between the database table and the Java object where we receive that data. That's done based on annotations on a project class. So we have here a company which we will store to the database or read from the database, and it has two fields, the ID and the name, and we have the classic getters and setters. In production situations, you also need to have the equals and hash code because that is important, but look in the documentation or on the internet what the requirements are for the equals and hash code for a JPA entity. So I mentioned already the name is entity. So by using this annotation, we mark that this class, this Java class, instances of this Java class can be serialized to the database and can be written from the database. We need to specify the name of the table. So I can specify here a certain name that can be something completely different, but of course it is recommended that there is some relation between the database table name and the Java class name. Within JPA, each entity requires a primary key, so it requires that you identify what is the unique, what uniquely identifies your record. So I'm going to put here the ID annotation on that ID field, which is a long, which can be any kind of number, so it does not have any business value. As you can see here already, my IDE, that these two are fields within the database, but we can make it explicitly and define some other properties by using the annotation at column. So we can here define a other name for the field in the database, like for some companies are using the best practice to prefix it with the table name, like company ID, but we can of course also keep it like ID. There are also a lot of other possibilities to define the length and if it's nullable or not, but again, that is only used when you auto-generate the database, which is recommended in production. And for consistencies, and I just put here also a name. So now that we have a mapping defined, we can try to read the records from the database. And there are two possibilities to read it. One option is that you use just a CDI bean for that. So I have here a class called company service, and by annotating it with the application scoped annotation, I can define it as a CDI bean. I use it as application scoped because that class here should not hold any data specific for your user. It is just for interacting with the database, so that should not contain any session specific data here, only methods that read and write to and from the database. The interaction with the database is performed by the entity manager. So we need an entity manager that manages, the name says itself, that manages those entities. And then we can, for instance, say that ask at the entity manager, find me any instance, not find company. We are going to find a company, but we need to find here a company with the primary key value 1. So this first looks locally within the cache if it's available, and if not, it reads it from the database. So we have now written the statement to find the company record within the database, but this entity manager needs to be injected here within this CDI bean. Normally we use with CDI the @inject, but the JPA is a bit specific, so we need to define the persistent context here, because there can be multiple entity managers. We have defined the persistence unit here. So we have defined here the test unit with that JDBC connection, but you have the option to define multiple ones. In the case you only have one, you don't need to specify the name of the persistence unit because the system knows which one to choose because there is only one. But in the case you have multiple units, you can define here the name of the and the unit name of the context that will be used for this entity manager because an entity manager is linked with a certain database connection. Since all database actions are transactional, we also need to specify here at the class level or at the method level that we are going to use every method here within a transactional way. With that transactional annotation there, a interceptor is added to our class, which starts a transaction at the beginning of the method. So when the method just starts, it starts the transaction, and at the end, it stops the transaction. So it commits the transaction if there was no error, and in case there was an exception thrown, it does a rollback. This is how you can read and write, as we will see later on, with a CDI bean from the database. But there is also the option to use EGB beans. We did not cover that yet within this series, but many of you are familiar with EGBs. So we can use the same constructs here. So we define a persistence context on the entity manager and a find method. But instead of annotating it with application scoped, we annotate it with stateless. So it is a stateless bean again, just as that CDI bean, it does not contain or keep any state of any user. So it is just for the methods that this class is created. By default, any EJB is already transactional, so you don't need to specify anything. But you can define how a transaction is created with the transaction attribute. You can define if it, for instance, is using an already started transaction or not. So you have a lot of more options with EJB than just with CDI, where you can just say that it starts and creates another transaction. So now that we have our methods, we have also here a test class, just a JAX-RS resource, where we define a endpoint which takes the ID and that it returns the company for that ID. And we have then, of course, as we already saw before, a activation for our JAX-RS with a definition of the endpoint. I have here a Payara server running. So this is a Payara 5 one, that's because as you know, you can also deploy Jakarta EE9 applications on it. You can also, of course, use the Payara 6 Alpha 1 or later the Payara 6 final when we have released it. I have already configured the database connections. We have a other video series how you can configure the database connections within Payara Server. So as you can see with the command list AWC resources, I have here that local MySQL that I'm referring to in my application. And I also have defined the connection pool. So this Rubus pool corresponds to that local MySQL. So you can find out the details about the link and the information about these connection pools and that EAWC resource within the admin console. So let's compile our application. We are using Maven, so I can do a Maven clean package this time. Then it package all the information from my application within a WAR file, and then I can deploy the application on the server. It is deployed successfully, and then I can use the curl command to access that endpoint, and then you see that I get a record back, a record 1 with name Payara. If we look at the data which we have loaded initially within the database, you see that that company 1 indeed is the Payara value. Reading and writing the Java primitives like long and string is not a problem because there are counterparts of that within the database. So I have now here created a other entity, it's called employee, and there we have two other types which requires a few additional configuration in order that the system can read and write them. One of the types is a enum. So I have created here a enum for the gender one, which has the values, the classic values. But how will the JPA system write this to the database? Well, that is something that we can specify with the enumerated annotation. And there are two options. The default one is the ordinal one. So that means that the first enum value receives has the value 0, and that's stored in the database as 0, and the second one is 1, etc. But of course, that is quite dangerous to use that default value, because if you reorder the values here, if I reorder the values of my enum here, that means that the value 0 in the database gets now a completely different meaning. So the ordinal one is not the best solution. So that means that you need to define a other one and that it's called, and that's the string type. So that means that the text of the enum itself, so male or female or other in this case, is written to the database. That means also that the database field needs to be a textual field and not a numeric field. Another type that needs some changes is the date type, because date can hold day values, like it is the August 25, for instance, but it can also contain the hour values. But sometimes we don't need those hour values. For instance, like here, the hire date, we are not interested in the hour when that person came in. We're only interested in the date value, so without the hour and minutes. That's also, we can also configure that using a annotation. That's the temporal one. So if we add the temporal one, I'm going to put it at the next line, that's better. Temporal type, we can specify three types. We can specify a date, that means only day information without the hours. We can specify time, which means that we only save the time information, or we can specify timestamp, which contains both the days and the hours. So for our hire date, the date is the most appropriate one. Let's learn now a bit more about how you can read multiple data. For instance, we have seen in the previous example that we are reading just one record, but you can also read all records from the database, all records from a table. Later on in the second part, you will also see how you can restrict the records that you are reading with the where clause, and how you can specify those parameters. But here, let's first see how we can read the entire table, and that's possible with creating a query. So we can create a SQL-alike query string. It's the JPA query language, which resembles a bit SQL. But the most important difference, of course, here is that you're reading Java objects. So everything is that you are writing here is related to Java and not to the database. But you also have that select keyword, and you select from a certain table. So you can select from table employee in our case. And we define there an alias, and we can say select all from employee. This will select the entire table. This query returns just object, so it does not know what to return. So we can say, well, that it needs to be cast to the employee class that we have before. And once that query is created, we can immediately execute it, so we can get the result list from that query. So this is the way how you create queries to the database, in this case to read all employee records. But as mentioned, be aware that you reference here Java objects, and later on, if you see the where clauses, that you also use the Java class name and not the database field names. So we can do a Maven clean package, and we can redeploy the application. And once the application is deployed, I can use the endpoint. I did not show the endpoint for the employee, but it's similar to the company one. So I can ask that here, that employee endpoint, and I see that I get a JSON result back with all the records which are defined in our data. So have a look at here the default data. You see that I have entered here 5 employee records with some data, and those data are all returned here from the query that we did, including it is using the correct values for the gender. And here, as you can see, there are specific requirements that the dates are then converted to UTC, which is different than my current time zone. That means that you don't have here is not the hour 0, but 23. So besides the date and gender, for instance, there are other types of specific requirements for conversions. You can always create your own converter. So let's see an example of that one. So suppose that we are storing the favorite color of the employee. Color is not by default known how that should be serialized to the database. So for that case, you can create a converter class yourself. A color converter, for instance, is the class name here. And that must then implement a interface which is called attribute converter. And that converts the value within Java, color in this case, to the database value. And we have chosen string for our representation. And that interface has two methods. You have to implement the convert to database column method, which receives then your color value from the Java, and you need to return a string, which will be stored in the database. And in my example, I have chosen to write the red, green, and blue value of the color separated by commas. This converter needs a bit more safety because it results in, for instance, a null pointer exception when there is no color assigned, but you get the idea how you can create a converter here. The same if we want to convert the database records again to a Java object, then we get the database value and we need to convert it to a color value, and that is of course possible by splitting that value again based on the commas that we find, and then use that as the red, green, and blue value for the constructor here. Again, some additional checks are required here. By annotating here the class with addConverter, the system knows that it is a JPA converter, and we can then use that converter at any place that we want to use it. And for instance, we have that employee here where we have that color, that favorite color that we want to store. So we can say use the converter with a certain converter name. No, it's not converter, it's convert. Convert, use this with a certain converter, which is our color converter class that we have seen a moment ago. And now the JPA system knows how to convert colors to and from the database. So that is the end of the first part of the video around JPA. In the second one, we cover the writing of the data, the parent-child relations, and the performance.